Welcome to the learning session. Today we are talking about we are talking about statistics for goodness of fit test for a discrete distribution. That's our topic today. And what we have been given is that we want to ask a question that given a person, given a star sign of a person, zodiac sign of a person, how likely is a person become successful later in his career? And as a representative of a successful people, we took the CEO, the magazine that is called Fortune magazine. They took a 500 out of 500. They took the star sign or zodiac sign of 256 heads of CEOs from those Fortune 500 companies, and looking at the data, this is data we have here. This is data we have, and what we see is that in this data, we see that Pisces is a bit more well represented than any other zodiac sign. So can we say that, hey, Pisces, if you're Pisces, then you are more likely to be a CEO of a big company? Can we say that? I guess not. That'd be uh, too too far-reaching to say that without any proper testing or experimentation. So the basic question remains: we want to know whether is an impact of the zodiac sign for people become successful, and we have this data. And looking at this, we want to we want to prove that even though it's a fluctuation data, it doesn't have any impact on a person become successful. Meaning meaning each sign have the equal probability of being successful. That is, if we divide 1 by 12, 1 by if you divide 256 by 12, then it can be any one of these signs. That is, it can be Aries, Taurus, Gemini. It is equal for everyone. That's what we want to prove. And that's going to be our null hypothesis here. That's going to be our null hypothesis. And if we can reject that, and we'll try to reject that, that's going to be our alternative hypothesis. So what do you think? Like, for each sign, we'll say that the probability is 256 by 12. What is a value of 256 by 12? It is 21.33, isn't it? Am I right? Correct. That's what it is. Now we want to know whether the probability of each sign is 21.33, or let's say 21. It's a 21. Even that will bring some fluctuation. Now moving on to the this data gathering process. Now second step would be to check whether each sign has a greater or lower probability than 21.33, and we can really test that whether Pisces have the probability of being greater or equal to 20.33, but that would be misleading, because if we do that, then we look at data and we are creating hypothesis. But it should be other way around. We should we shouldn't look at the data, but we should create a hypothesis in a class, and then we should go out and collect data to prove or disprove our hypothesis. That's the way it should actually work. Not that we look at the data and then create a hypothesis. That's called cheating. And because of that, you can get into trouble later. Now, let me quickly summarize what we learned today. We learned about data from the Fortune magazine, and it gave us a table for a tally of how many CEOs are there for each sign. And we saw that some signs have more number of CEOs. I want to prove that it is just a fluctuation, not a fact. It is a fluctuation, and we want to prove that each sign have equal probability of being a CEO. And then we can move on to saying that whether a particular sign has a more probability of being CEO than any other else. And then we can explain that, oh, Pisces is the one that has a more probability. So that's all for today. I'll see you next learning session. Thank you so much.